I'm Jeff Carmio. I'm a product manager at IBM in the high-performance computing group with IBM Cloud. And what we're showing here today is a hybrid classical HPC and quantum workload. Our clients are more and more working with hybrid workloads where certain parts of the problems are being solved with classical HPC, and there are parts of the problems that are more suited to be solved with quantum, and that actually are pretty impractical to solve with classical HPC. And so we have this workload that starts off with running a couple of classical HPC jobs. One to figure out the right position of the molecule. The second one does a transposition and actually lays out the circuit in the quantum system. The third will run it through a quantum system, and it actually executes quite quickly. And the difference here is if we try to run that in a classical HPC system, it would take 10 times the amount of equipment and may never exit. It may never complete. But here in quantum, it's well suited for that. And then we have a final set of workloads, a final job that takes the results from the quantum job and visualizes it.
So it's like a hybrid workflow?
Yeah, it's a hybrid workflow.
Before the quantum computer exists, you were already planning out what will be the hybrid?
Yes. So we know certain parts of the calculation are well suited. Like a lot of physics and chemistry equations are very well suited for solving in quantum. And so the whole workload, the first part of the workload is all classical HPC, where the data is all prepared. It does some analysis to figure out what's the best quantum circuit to use. It then sets it up in the quantum machine, runs it in the quantum machine, and then collects the results and visualizes the results. And it's like we see quantum as part of the hybrid workload, just as today, a classical HPC workload will be your GPU, your CPU-focused part of the workload. You'll bring specialty GPUs in for part of them, so maybe building a model or so, or maybe you'll bring an FPGA in for a certain part of the workload, and now you're bringing quantum into the workload, and it's an evolution. HPC, it's an evolution that has been running for almost 30 years. We've been working in this industry, and you just over time, as new methods come, we continuously expand our capabilities to handle those different methods.
Do we already know what's the best source code to feed the quantum computer?
The quantum computer is the IBM quantum system. Actually, this whole workload runs on IBM Cloud. And to feed the quantum system, we use the language called Qiskit. And LSF, which is our high-performance computing, our batch scheduler, has an integration with Qiskit, so we can very easily submit and control the workload through Qiskit and through a single control plane. So we use LSF as a control plane to manage the entire workload, and at the right appropriate moment, LSF calls quantum using Qiskit, executes the code, and then when it gets the results back, and then takes the next step in the quantum calculation.
Is Qiskit, why is it the best fit?
It's the best fit because that's the language that the quantum engineers have chosen to start with, and so that's what they're using right now is Qiskit. So you have to integrate with Qiskit to be able to work and interact with the quantum machine. The quantum machine is running on IBM Cloud, and so is LSF running on IBM Cloud. So it's two cloud environments working together, all on IBM Cloud, to be able to deliver these results.
So are people just going to be able to get on IBM Cloud to get access to the quantum computer?
Yes, yeah. Even today, you can go and you can apply and get some free access to the quantum computer. I'm not sure, I think you get about 10 minutes a month of quantum time, but you can start experimenting today. So if you're a researcher or a scientist, or you have some idea of what you think the right kind of algorithms are to run in quantum, you can start playing with it, simulate it, and then submit it to a real quantum machine and see how it executes.
All right, and it's right there. There's like in the front of the booth.
Yes, the beautiful golden chandeliers at the other side of the booth. You should go over and look at them. It looks golden because it actually is made out of real gold, because gold is such a good conductor of electricity.
HDMI technology powers the global ecosystem of connected devices, enabling advanced displays that deliver immersive visuals and sound across entertainment, professional, and everyday applications.
As the preferred technology for digital AV connectivity, HDMI technology and the features and benefits it enables
links billions of products worldwide, from HD TVs, set-top boxes, and laptop to gaming consoles, projectors, and audio-video receivers. It provides the reliable, high-bandwidth connectivity needed for today's ultra-high-definition video, lifelike color accuracy, and immersive sound formats. HDMI technology drives innovation across industries, including digital signage, medical imaging, education, and esports. With unmatched performance, interoperability, and scalability, HDMI technology continues to define how content is created, shared, and enjoyed around the world.